Greetings again, and welcome to week 7. This week, your assignment is to read chapter 7 about lists and tuples, which are fun words to say, at least tuple is. Lab 7 has 3 parts to it. Don't forget your project's due. But let's jump right into, we got a lot to cover. I'll break this down into 2 videos. We're going to talk about sequences, what they are, lists, list slicing, all kinds of functions and operators that you can do with lists, methods that are part of lists as well. We'll talk about working with them, and that includes copying them and some other things that we can do to process them. In the next video, I'll get into two-dimensional lists and tuples, and the difference between a list and a tuple, and we'll talk a little bit about plotting graphs using Python with the matplotlib package, which, you know, when you start talking about x and y coordinates and plotting things on a graph, that would be your two-dimensional lists. So let's jump right in. A sequence. What is a sequence? It's basically an object that contains multiple items of data. And we'll see what this looks like in code shortly. Python has 2 types of sequences, lists and tuples. The difference, as the book will tell you, is that a list is mutable and a tuple is immutable. What does that mean? What is mutable and immutable? Mutable means something can be changed, plain and simple. Immutable is the opposite. So that means if lists are mutable and tuples are immutable, you can change the items that are in a list, but you can't change the items that are in a tuple. So again, what do we mean by multiple items of data? Well, here's what a list would look like. Again, a list is just an object that contains multiple data items. And it's an object, which means that opens up not just functions to use with them, but also that dot notation that we first started discussing last week, and talking about methods. So variable name dot some method, which are called like functions, only with that dot syntax. So a list looks like this, and there's a new operator there you'll see that is a square. We call those square brackets. They should be on most keyboards next to your P character, above the semicolon and that kind of stuff, off to the right-hand side. But the square ones, not the little curly ones, and certainly those are not parentheses. Those are the square brackets, okay? A list can hold integers, floats, strings, or some combination of all of them. Actually can actually hold different types of variables. You can use the print function and pass it the list variable name to print out the entire list. And there's also a function that you can convert certain objects to lists. So how does this work then? How does a variable actually hold more than one value? Think of it like a series of boxes. If you or a family member takes pills and they have one of those, 7-day-a-week little pill boxes that holds pills for each day of the week, think of it like a pill box almost in that respect. Or a child's toy where there's multiple things that the kid can make pop up out of the box or whatever. And you can have almost anything you want in it. You can have even numbers. You can have a list of strings, like I said. And again, you can have multiple variable types, data types, inside one list. We were talking about files last week, and we talked about a couple of different things. One of the examples we had was about coffee. And we had different types of coffee, and then and that was a string. And then we had the amount of coffee that we had on hand in terms of pounds, and those were floats. So again, same kind of thing here. We also had employee information. We had their name, the department, and an ID number. So again, you could use lists for those kind of things. It makes working with lots of data and complex data sets a lot easier. So let's actually look at this. Let me just launch some Python here for us and get our favorite interactive environment here, and we'll do some of this. So and again, if you're following along the book, we're already up to figure 7.1, 7.2, and 7.3. But again, I'll just do, I'll keep this short. We'll just say even numbers, which could be 2, 4, 6, 8. I can type 10. And again, it's the square brackets. Just assigning a variable the same way we normally would. I can also say names equals, and we want our curly bracket in there, Molly. These are strings, mind you, so we need all our all of our double quotes in there, or single quotes, whatever you prefer to use, as long as you keep it consistent. And those are names. And then we'll do info, as the book says, which again is a list format, and we might have Alicia, 27, and that number, whatever that is. Maybe it's this week's pay. How nice for her. All right, so we have 3 list variables now at this point. So we can say, we can use the print command. And if I can type, it's not event, it's even, print even, there's our list, right? We can say print names, same kind of concept. And notice the notation when it comes back with that print statement also has the curly brackets along with it. I can also say then print info, and then you see that our three different variable types in that same list all print out just the same. What else can we do with list? Because that does seem a little redundant and dumb, doesn't it? The repetition operator. You can make a copy of a list or copies of items in a list by using the multiplication symbol, the star, if you will. So if I want to say, if I want to repeat something, let's say, I might say, let's say double. Double equals even times 2. What will this do? Well, again, the repetition operator, we're saying we're going to make a repeated sequence. So if we're repeating the sequence times 2, we should expect double to be 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. And if I say print double, 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. Again, same thing. We could say triple equals even times 3. And print triple. And we see it's repeated 3 times. So same kind of concept there. You can also do the same thing using a for loop. So you can say when you want to work with something for, X in list. So let's just see how that would work. Let me actually make a new file here. And we'll use names this time. So I'll say names equals that. I'm not going to put on errors with comments and that kind of stuff. This is just for demonstration, but we'll say for each name in names, colon, and we can say something like, print each name. Okay, and what that does, right folder, and we're good there. And you see it just prints out each name one at a time. Now, note, why when we printed names out before, did it have everything with the square brackets around it and each one with quotes and whatnot? Well, that's because it was printing out the items of each list, the items together as a list. What this code is saying here is this code says, hey, for each one of these things individually, for each individual element in this list, print just one of those elements. And in fact, we could do the same thing here, and we could say, we used to have this before. One of the first things we learned with the print statement, separation equals, let's just do a few dots here, right? And the separator between each name now, instead of being a new line character, should be this. So if I run this one more time, I messed it up somehow. And that would be because each one of these is printing in the loop. I actually want to do end equals that. Because then it won't print the new line character because it's the only one print statement before it repeats that loop. So let's try that again, and that's what we're looking like here. So again, it's printing out each individual element of the list when you iterate it with a for loop. And again, just for clarity here, we'll say print names. Do a few more prints here just to get some separation in there. That's not what I want to do. All right, and just to clear this out a little bit, and again, one more time, let's run this, and again, you'll see. So the first thing we're going to do is print the entire list out, all the elements together as the list. Then we're going to iterate that list, again, just to show you how this looks. The first one being our list. The next one being this iteration, going through each one of these. And you could work with any kind of list, right? So each individual element, we can actually say, let's do this. Let's just copy our evens here. Evens equals that. Let's clear some of this out. You get the idea. Working with these, let's just start this all from scratch. For number in evens, we can say print number mod 2, and really what we should get each time is a bunch of zeros, right? Because if you divide something by an even number by 2, you will get, actually for the first one we should actually get the factor of 2 that it is. So 1, 2, 3, etc., right? Because 2 mod 2 should be 1, 4 mod 2 should be 2, etc. And again, just to show you, or did I get all zeros the first time? Because that's what I was saying. It's the remainder. It's not the, if we did the integer division, that's what we're looking for. There's our zeros. I'll be all right. It's been a long day. I don't know how it's been for you. And there's our 1, 2, 3, 4, 5 if we did it with the integer division. But again, it's not just, hey, here's a item from the list, print it out. We can work with these things. There's still elements inside the list. It's just kind of like an extra long variable, or multiple variables, if you will, with one name that we can just iterate through. And again, we do this using the for and in notation here. So for some variable, just like you would with a for loop, and instead of saying a range, you say in list, because that list effectively becomes your range, and you can iterate across the whole thing. Indexing. What is indexing? Well, indexing is basically the position where an element lives, right? And again, very much like when we're counting with a range that only has one parameter to it, we're going to have the list starts with 0. So the first element in a list is actually 0. So if we look at this in our code here, this is position 0, this is position 1, position 2, position 3, position 4. Okay? And we do this using the index. Basically, the index is the actual thing, and then there's commands we can use. Let's keep going, and I'll show you what they look like. The other special one, actually, is the -1. If you don't know how many things are in a list, and we're going to talk about reading whole lines of text later on, from a file, perhaps. And if you choose an index of 0, that's the first element in the list. If you choose an index of -1, that is always the last element. -2, second last element, and so on and so on. And you can use those to reference positioning inside of a list. There's also a function called the len function. Okay, and len tells you how long a list is. So again, let's come up in here. We have names, we have evens, we had double in here too at one point, right? And triple. Let's go back and find those, and let's paste those right in there. Okay. Let's just say, well, we can just do this, right? Evens equal, let's see, triple equals evens times 3, right? All right, now the len function. Print len names. Print len evens, and print len triple. And again, all this does is it tells you how many elements are in each list. So we have 5 names in our names list, we have 5 digits in our evens list, and we have 15 because it was these 5 3 times in our triple. Again, len is just a function that says how long is this list, basically. Here's an interesting one. empty, you can actually create, just like we can initialize a variable, a string to, two blank quote characters, you can initialize a list to just an empty set of square brackets. So if I ask for the length of that, I will get length 0. Again, there's nothing in it. Okay. Lists, we said, are mutable, which means you can change them. And what do you mean you can change them? Well, you can replace values. You can add a value to the end of it. You can actually add a value anywhere you want in a list. You can change the order of things in the list. And again, you need to know where things live. So again, guess we should probably address this at this point. I'm going to work just with the names for this. Okay? And let's talk about some things here. First of all, notation. We talked about the index of a list, and I said the first element is always element 0. We know we have 5 things in this. I'm going to do this. I'm going to say for, I'll just use X for right now, in names, I'm going to say, nope, let's do this. Let's not do that. Let's say for, we're just going to iterate through this. We'll just call it a loop. And we know we have 5 elements in our list, right? So let's use that. Let's see where this takes us. 5 elements in our list. I want to print out, we're going to start with, we'll say, just to make this very clear, we're going to say position. And then we say names loop. Now, what is that going to be? Well, the first time through, it'll be 0. Then 1, 2, 3, and 4. Correct? Names loop, because 5 is not inclusive in a range that looks like that. 0, 1, 2, 3, 4 are our 5 elements. Okay? Ironically, we have 0, 1, 2, 3, and 4 in our list. And now you're starting to realize maybe why it starts with 0 and ends 1 shy of the number of elements you want when you do the range. So position, names loop, I'm going to throw a colon in there and then a tab, and then we will add, nope, have this a little backwards. We're going to say position, comma, loop, which will be our number. Then we're going to say this. Okay? Okay. Change my mind halfway through. What am I doing? Position. It's going to print out the word position. Loop will be the value of loop when we go through. So the first time it's 0, the next time it's 1, etc. It's going to print a colon and a tab, and then it's going to print names bracket loop. What is that notation? Well, that's essentially names bracket 0 the first time through, or names bracket 1, etc., etc. And again, this is our index. Okay? So let's just save this and run this, and you'll see what it looks like. Invalid syntax where? Where's my syntax? Because, silly, we forgot the actual word range. Alright, so save. If you ever just had one of those days, just like 4x in lists, I haven't worked with for loops in Python in 2 weeks. Okay, for loop in range 5. Regular for loop. We're on this now. Again, we're going to print the word position and the position number. We're going to print a tab, and then we're going to print the name. Hopefully now, there we go. I've got that right. So yeah, this is what it looks like, right? What are we essentially printing? We're actually printing names bracket 0, names bracket 1, names bracket 2. And notice that it references, well, it prints out the value of each one of those positions. That's what the index does for you. Okay? And again, this is no different than simply saying this. Just to kind of go over this one more time. Just because I am lazy. And these should, in effect, print the same thing. well, at least the same values. Okay. That is the notation of how you reference something in the list, the index, if you will, by index number. Okay. And again, we can iterate this via a loop, or we can iterate this via, well, either a range loop or with our little shortcut, we can reuse that at this point. In this case, loop would be defined as just that. These two are effectively equivalent. And again, I'm not printing off the position stuff, but you see we're getting the same things from each of these loops. So now, back to where we were before, we can change things in a list. So we can simply say, and what lists do I have here? We'll just go back to using this. If I have, there's our names for our variable, and if I say names, let's take out Stephen. Sorry, Stephen. Stephen will be number 1 equals George. Really just having that day. And what we've effectively done now is said, okay, forget whatever was in position 1 before. We're going to make that George. So now if I actually list out what's in our names list, you see Stephen has been replaced by George. Okay, all kinds of neat things. We can add 2 lists together. That's always fun. Let's say names 2 equals, we'll add Stephen back in here, and we'll say Grace. We have a Will, why not have a Grace? Okay, and there's our second. What did I do wrong? I actually did this. Maybe I should just stop typing for the day. All right, names 2 equals that. Now, what can you do? You can join 2 things together. So we can say new names equals names and names 2, which are our 2 lists. And we can print out the list of new names, and look, they're all together. And see, they just took what Python does, what the interpreter does, is it takes the first list and just adds whatever you added on afterwards. Just kind of joins them together. Okay? We could also do that in the same way here. We can say new list. Nope, we can, if we wanted to do that with, and just add to this list, right? We have names. The augmented assignment operator also works. So if we wanted to say names equals names plus names 2, we can do that, or we can use this. Okay? And now when we list out names, it shows us all, just like new names. Okay? So yeah, concatenating plus sign to do that. The augmented assignment operator, the plus equals, works the same way. What else can we do with lists? These are starting to get a little repetitive, aren't they? A slice. In math, you might call this a subset, right? It is just a bunch of things that are taken from the list. And you can, we got a nice long list here now we can work with here. So we have, how many things do we have in this list? Look at that, we now have 7 things in this list. Well, what if we wanted just the first few? We can say, if we don't specify anything, we can say, let's see. We can say names, let's just say, let's put this in a print statement just to make it more clear. Names 0 to 3. We give it a start and we give it an end. And just like a range, in a similar fashion, it's going to give us 0, 1, and 2. The 3 is not inclusive. We're going to start at 0 and go for 3. In a similar vein, we can say start at 1 and go to 4. And now we'll get George, Will, and Alicia. Okay, and again, just so I didn't show this before either, I kind of basically said, here it is, and trust me. But if we use -1, we'll get grace. Interestingly enough, if we say -1 and go for 3 of them, we get an empty set. So while range is, while slicing is similar to ranges, understand how these all work. The in operator, we already saw this when we showed the for loop, item in list. The function itself is a Boolean operator, and it returns a value of a Boolean. And why would you do something like that? Well, because you want to see if something's in there or not, if you're looking to search something in a list. And again, think about the coffee example we used in last week's lecture. When we were trying to change the value of how many pounds of coffee we had in something, we opened the file, we typed in a string, hey, we want to change Kona, we want to give it a different value, and it went through and it looked, and if it found it, then it was good, and it changed the value, and we went our merry way with the program. You still want to do something similar to that in lists as well. So, and for that, for the coffee one, we iterated this like, one word at a time, it was a string. Now we can say, okay, is this in the list? So you can say something like, well, we'll just say this, because remember this will print a Boolean, right? It returns a Boolean value. So we can say print will in names. Now is will in our names? Sure is. And we get back a true. If I say print Jack in names, we get a false. This makes it very easy for us to do neat things with our finding, basically. So let's clear all this stuff out. We know how to print them. We know how to index them. We can say if Jack in names print Jack is in our list. Else print Jack is not in our list. Pretty simple. And if we run that, we know Jack is not in the list. We can also do something like this. Just say person equals input. Who are you looking for? Look at that, I can type today. Let's come back, and we can say if person in names person, comma, is in our list. Person, comma, is not in our list, right? So now I can start saying, oh, I'm looking for Will. Will is in our list. I'm looking for anything. Not in our list. So the in list function is not just for repeating things and going through a loop and iterating to go through the list and see. It can return a very quick, hey, is this here or not, true or false. So before you go through all the processor cycles and memory burning through of looking through a long list of something, you can have Python do a quick check. Is it in there or not? And that way you don't have to iterate each one of the lists, each item in the list each time. Very simple statement. And again, you could also use the not in operator too, right? So if person not in, we can basically simply say, sorry, person is not in our list, right? I'm looking for Will. Nothing happens because I didn't give it anything to do. I'm looking for Jackie. Sorry, Jackie is not on our list. So, in list and not in list. All right, what else can we do with lists? I promised you a whole bunch of stuff. More built-in functions for working with the list object. Append, index, we can figure out where things are. We can add things to the list, unrespectively there. So let's take them one at a time. We'll say, who do you want to add? And we can say names. Here we go again. Names that append person. Okay. Print names, just so we can see the list. Okay. Actually, let's start at the top here. We'll say print names. Okay. So what this will do, it'll print our list of names out. It will ask us who we want to add. We'll add it onto the list, and we'll print the list of names again one more time. So there's our list. 5 names. Who do we want to add? We've been looking for Jack for a long time. Let's add Jack. And there you go. Jack gets added onto the end. Okay. Now we can say, hey, where did Jack get added, though? So we can say print names dot index of the person we just added. So what will this notation do? So we already know that we're going to add a person. We're going to append that, which will go to the end of our list. But if we didn't bother looking to see how big our list was, we might want to know how big it is now or where it got added on. In this case, that's the same thing. But we can say, where is, what index level, what part of that is that? So we can actually say, that. Let's save that. Molly, Stephen, Will, Alicia, Adriana. We're going to add Jack. Jack is added into spot 5. We could actually say this. We can say person, just to make this a little more clever, is in position, the index, of len names. And one more to close. Yes, that's good. So now we can say, where is this person once we added them? So invalid syntax, because we forgot our comma. Commas everywhere, yes. Who do we want to add? We want to add Jack. Jack is in position 5 of 6. But wait, I thought it was in the last one. Oh, yes, but we start at 0 of a list that is 6 items long. So while it might seem obvious that it's the last one, it's just letting us know it's at position number 5. That would be the index out of 6 in the list. Now, if you wanted to count like a human and give some user-friendly output, you'd want to actually use index of this plus 1. Okay? Just for that human-readable output. Because humans count starting with 1, not starting with 0. The index tells you what position it's in, but if we're counting starting with 0, then you'll want to, in a human form, when you're giving feedback to the user, unless they're specifically asking for some kind of programming tool where you'd want to know the index position, the position in your list, Molly is the first one, Jack is the last one or the 6th one, and that's where we can use that from. All right, so that's append, that's index. I'm not going to go through each and every one of these. That's what your experimentation is for. It's what LabTab is supposed to be for, but we're online. So, insert. You can actually say insert somebody at a certain position. So, in kind of the opposite of append, let's clear all this out. Just leave that there for right now. Instead of saying append, we can say insert. However, insert takes 2 arguments. The first thing you want to know is where you want to put them. So let's say this. We can say pos for position equals, we're going to change this to an int, input. Where do you want to add person? We'll just finish it off to make it look nice. Close that off. That should be good. And now we'll say insert, and the first item is actually where we want to put that person. So that would be pos. And the item, but this is, insert. So names.insert. It's our dot functionality, the insert method, the index, and the item we want to add. We want to add Jack at this index position. And then we'll print names one more time, and we'll say, again, the same stuff here. So actually, I'm going to take that off for the moment. So If I didn't type anything wrong, who do we want to add? We want to add Jack. And we can't do that with our prompts. So we'll just say, where do you want to add for now? That's fine. We want to add Jack. Where do we want to add Jack? Let's say we add Jack. Now this is going to be by zeros. Let's say we want to add Jack right after Will. 0, 1, 2, 3. We want to add Jack at 3. And look at that. Molly, Stephen, Will, Jack is at position 3 of 6, which is actually the fourth one in our list. Okay, that's how insert works. Sort. We can actually sort the elements in ascending order. So for numbers, that would be alphabetical. For names that were for letters, that would be alphabetical. Strings and letters, that would be alphabetical. For other values, that might be in incremental order. So we still had, and there's reverse, which I'll do first here actually, because we had, what did we have? We had evens, right? Even, was it just even? Did I close those all out? That's all right. Let's just say this. Just say some random numbers. Equals 1, 5, 9, 66, 4, 3, 12, 7, 6. We didn't use a 6 yet? Good. All right. And 2. Okay. And we could say numbers.sort. And now we can print out numbers, which is actually now in the right order. And again, similar things. We can you can use reverse, which will reverse that all out. Now notice, this is not a formatting thing. This actually is sorting the numbers out. Okay, and if I try to print one of these methods, the method still applies anyway. And now it's reversed. Perform that again. And it's reversed again. So reverse just reverses the order. Sort actually sorts them in a forward order. And remove, you can remove an item from the list. Removes the first occurrence of item. Here they all are. All the ones we're going to be working with and worrying about, at least at this point. These are also in your book. So know them, learn them, play around with them. There's a whole bunch of examples in the book of what you can do with lists and their methods and functions that go along with them. So kind of work with those. There's a delete statement. Now this is different than the remove statement. The delete statement actually will delete a specific element from the list. Not going to bother with that right now. The delete statement will actually delete, and you notice that you're giving it a position. You're giving it an index position. That's what the I is standing for in this. Delete, DEL, list name, bracket number, and whatever positioning you want. Now, you want to make sure, this is one of those things that will throw a value error if you get the wrong indexing position. If you have a list that's only that's only 5 things long, and you try to delete 6, it's going to give you a value error. There's also min and max functions. They show you the highest or lowest value in a sequence. Why don't I pull up a program here? We'll see. Go back to our coffee thing here. A whole bunch of things in this program going on. So this is in your book. It's somewhere in 7.3 or 4, I believe. Megan has a coffee shop. She's got, I changed this to 3 baristas just for the sake of brevity. So what does this program do? Well, it starts off with hours, and it makes 0. It initializes the list to 0 times num employees. Well, what does that do again? Oh, yes. That will make however many employees I have here, in this case 3, it'll make 3. Now, does that mean I'll make 3 zeros? Yes. You will actually have a list called hours that will be 0, 0, 0. Okay, it's not 3. It's not 0 times 3, and you still have a 0. It is, you are repeating that 0 value 3 times. Remember before we had the evens, we said 2, 4, 6, 8, 10 times 2 for the double variable that we had. And it was 2, 4, 6, 8, 10, 2, 4, 6, 8, 10. It repeated the pattern. The pattern of this one is just 0. Repeating it 3 times is 0, comma, 0, comma, 0. Next, what does it do? Well, we have a loop for index in range of number of employees. So basically, we're going to loop this 3 times. Printer the hours worked by the employee. Okay. Great. Index plus 1. Well, what is index? Well, it starts at 0 plus 1 colon. Oh, I see. It's just printing out this nice little prompt for us. Hours index equals float input. So we are taking an input of the number of hours worked. And since you can work a half hour or a quarter hour, we have it as float. Get the hourly pay rate. Once we're all done with this loop, so we're going to take the loop 3 times, inputting the number of hours by each employee. Then we are going to have how much do they all make. Hopefully they'll make the same amount. Then it's going to print out the gross pay for each employee. Again, index plus 1. So again, we're not starting with with employee 0. We're starting with employee 1, then employee 2, then employee 3, because humans count starting with 1, not starting with 0. Notice that we have a dollar sign. Notice that we're formatting it using a format command, not a string, for 2 decimal places. Okay? So, what will this do? Let's just run this up. And we need to bring this over here. Enter the hours worked by employee number 1. Remember we said index plus 1. Let's say the first person worked 10 hours. The next person worked 20 hours. Let's just make this simple, and 30 hours. How much do they make per hour? Well, let's be nice and say they all make $15 an hour. Gross pay for employee 1 is $150, $300, $450. Very, very simple as far as iterating through all of these things. More of how you work with these, right? We could also say something that we want to work with the max and min. Print the most hours worked was, and then we can say, what was the name of the hours? Hours dot max. Nope, it is max because it's a function. Hours. And if I spell right, there we go. That should be right. It's a function. That's how we call it. We'll do this one more time. 10, 20, 30. They make $15 an hour. The most hours worked was 30. Similarly, we can do the same thing for min. The least hours worked was min. Cool. So again, lots of functions. One more thing that should be noted here is when you're copying a list, it does not work the way we might expect it to. Copying a list actually only references what's called the memory location. So list 1 might be these 4 elements, 1, 2, 3, and 4, and it lives in this spot in memory. If I say list 2 equals list 1, it doesn't actually make a copy of that list. It doesn't make 1, 2, 3, and 4 for list 2. It actually says, okay, wherever this is in memory, go point to that. If you're familiar with the C programming language, anybody who is, that would be the concept of pointers there. So let's do this here. Let's say letters. A, B, C, D. Okay. Back to that typing thing again. Letters equals A, B, C, D, A, B, C, D. Letters. Okay. Now if I say alphabet equals letters, we see we have the same thing. Now, if I say letters dot append E, and I look at letters, to no surprise, we have A, B, C, D, E. But what might be to your surprise, if I type out alphabet, I also have A, B, C, D, E. Because when you copy a list using this format, list 1 equals list 2, they are actually one and the same list. If you want to truly copy a list, there's two ways you do it. You can create a new string. Okay, shrink this up so you can see everything that's going on here. Create a new empty list, not new string, a new empty list, and use a for loop to iterate through it. For entity in letters, append, alphabet.append, and the element. Or another shortcut you could do is say, let's say, new letters equals that plus letters. Now, letters is still A, B, C, D, E. New letters was a blank element with letters concatenated to it. And now if I say letters dot append F, letters gets it, but new letters does not, because it's not an exact, it is a complete new list with its own elements. It is not pointing to the same memory location, because I didn't do new letters equals letters. I did new letters equals, hey, a brand new list, and add all these things on to the end of it. So that's the difference with a plus appending operator as opposed to just copying things back and forth. All right. The other things you can do with lists, and the importance of a list, is that you want to process them. You want to be able to go through them and do things with them. I kind of did a little before, but each individual element you can use in a calculation, like I showed you before. We can look at them. We can add +1 to them. We can do all kinds of neat things with them. You can use an accumulator variable to accumulate a list. So what would a list be? Think about your grades for your labs, for example, or any grades for that matter. There is a program in your book. Let me see if I can find it here. Bring this over here. This is the total function. Again, somewhere around in the section that talks about processing lists, which I believe is section 7.4 or 7.5. So what do we have here? We have just a main function, and we have a get total function. Let's see what we got. Main is pretty short. It defines a list of numbers, 2, 4, 6, 8, 10. Print the total is this. Prints a total, which calls this function. What does the function do? It's a variable called total, local to this function. For number in value list. Oh, look, we passed value list. What are we passing here? Look, get total numbers. Wow, you can pass a list to a function just like you pass any other variable, because it is still a variable. It's an object, but so are ints, or so are strings. So you're passing get total, a list. In this case, the numbers that we defined up here. So we define this variable total for number in value list. Total, here's our accumulator, plus equal num, which would be each individual element, 2, 4, 6, 8, 10, and then it returns the total, which is why we can say print the total is this. So when we jump through here, if it doesn't open on another screen, we see the total is 30. Oops, sorry about that. We see the total is 30. 2, 4, 6, 8, 10. We get 6, 6 and 12. 12 and 8 is 20. Plus 10 is 30. Pretty simple there. You can do all the math. You can do all the normal things you do with each individual element from a list. So a function not only can get a list, it can return a reference to a list. So you can save the contents into a file. We'll go through this really fast. Let's see here. want to open a file here. I want to open probably this last one here, right lines. We'll drag this over here. All right. Very simple example using the file objects that we talked about last week. And what are we going to do with this? We are going to actually talk about a method we used last week called write lines when we open a file handle, file object. And it does not automatically write the \n. Remember when we did write, it would print out whatever we gave it and a new line. What we gave it and a new line. So everything was on one long line. Write lines actually can write an entire line at a time, and then it prints it just doesn't print the new line. It just keeps going. You can use a for loop to write each element. So that's what it does here. So we have a list of cities, 4 things in our list. We open a file called cities.txt for writing, and then we open the out file write lines. We use the write lines method to write the whole list of cities here. Now, if I did this, let's just open. Let's open our shell here. If I did this, and said, here's our list, and I didn't indent it, well, again, it's one of those days. Here's our list of cities, okay? And if I said print cities, we get that. So what write lines is going to do is do the same thing. It's going to print that same kind of thing only to the file. It's going to write the whole line to the file, and then it's going to close the file out because that's what we do. That's just being polite. And we see nothing apparently happens here. But if I go over to here and I look for cities, which is here, we can see, oh, look at that. Okay, and it prints all of them together, but that's not really a great output, is it now? So let's try a different way here. Instead of using write lines like this, let's try to iterate, which there's nothing wrong with if you're writing an entire line out and if it was formatted to look nice in the file that you were writing. That's a perfectly acceptable method. Let's try this a different way though. Let's say for item in cities, put our colon at the end. Did I spell that right? Yes. Okay. We'll say outfile.write, which just prints one element at a time, and we can say item, and we can add the new line character if we like. Save that. Okay. We'll run that. Doesn't apparently do anything, but if we come over here and look at our cities file, now our file has all 4, one on each line. More like we did last week. What if I did this? Many spreadsheets and databases will export something to what's known as a CSV, a comma-separated values list. And a CSV file is basically a list of things separated by commas. So if I change that new line character to a comma, just save this and run it, and it won't look like anything happened. And we look at our cities file again now, we see we have all of our stuff separated by commas. So then what we do then, and I know I'm running a little long on time here, is we can figure out if this is the last item, then don't print the comma. So that might involve something like this. Outfile write item if the item is, let's just say in this case, just keep it simple. If the item is equal to Dallas, or if item is equal to, let's just say this, cities index of -1. That should work. Then, or we'll say if it's not, then we'll print, nope, we're going to do outfile.write, comma. And we don't need to worry about an else because we only have one condition that we're looking for here. And invalid syntax of what? Well, we don't really need that. And when we run that, and we go back to our cities thing here, now we have our list, and the last one does not have a comma after it. That's kind of a way that we can hopefully have summed up all the different functions that we can use, or many of the different functions we can use. And we'll do more with this in the next video, because like I said, I'm running long on this one. But let's absorb all this. Let's why don't you go through the book, practice some of these. As usual, if you have questions, please throw it in the weekly Q&A discussion board, and or send emails if you have to. But let's try to help each other's problems out with the discussion board. I try to be active in there as well and answer your questions. Practice with these, and we will see you next time.